Hello, everyone. Dr. Ripley here, and this is the first of our videos for our biostatistics class. And I want to start by defining what is statistics and talking a little bit about why we want to use this, what kind of tool it is for scientific thinking. Now, these definitions on the screen all relate to collecting, organizing data, large amounts of it possibly, um, we want to study how things vary in nature. Now, in engineering, that isn't quite so much of a problem, but when we look around at the natural world, we see that there's differences between individuals, between species, and statistical tools allow us to try and make sense of that and see what the overall patterns are so that we can understand nature. It also helps us manage uncertainty. So while there are differences between individuals, we don't know why there are differences between them. That is something that we might not feel comfortable with, that we might feel uncomfortable with the idea that we can't know something for sure, right? So it's an approach where we're actually going to, you know, measure uncertainty so that we know how uncertain we are. And there's a certain level of certainty in that. All right. So you may be worried there's a lot of math in this class. It's algebra, basically. And I'll go through and review everything you need to know. And you might be surprised if you get to the end of the semester and you realize the math is the easy part of doing statistical testing in the context of learning new things about the world. Also, there's some misconceptions about how statisticians might try and manipulate the data to show something that it doesn't really show. And certainly, ethical scientists aren't going to do that. But there's a lot of people in the popular culture, certainly on social media, that may be trying to convince you of something. Also in advertising. And the tools that we're going to learn, thinking tools, not just mathematical tools, are going to help you be able to, avoid being baffled by any of those kinds of tricks, and so that you can make your own decisions using proper tools of logic and reasoning. All right, so I can give you a quick example of why we need statistical tools. So think about a place where you go, somewhere different from your home, whether that's work or school or to a friend's house or whatever, relatives, grocery store. And if I asked you, how long does it take to get there? Think about what you might answer. Right. So for me, driving to the college, I know it takes me about 20 minutes. I'm a statistician, so I'm not even going to feel comfortable giving you a single answer, right? Because sometimes there's a traffic jam and it takes longer. Sometimes I miraculously hit every single light green and I get there a little quicker, right? So there's an example where we have some variation. Right. Now, we know that that variation is due to certain factors when we're looking at an example that we're familiar with like this. Like I said, maybe there's traffic, maybe there's, whatever stoplights, there might be, I need to get gas or something that's going to make me take longer. I forget my wallet and have to come back to the house, anything like that. All right. But statistical tools are going to allow us to say, well, the average amount of time that it takes me is going to be some number, say it's 15 minutes. Sometimes it takes me a lot longer than that. Sometimes it takes me a little quicker, but I'm going to be able to find a time uh, that 95% of my trips are going to be shorter than that. All right. So if I want to be sure that I'll get to work on time most of the time, I can figure out a time that is going to be that for me. Now I have to take the time, I have to measure the time that it takes me many, many times so that I have a good sample representing that. All right. So, oh, and your personal comfort with being late is going to help determine where you set that limit. All right. So those are the kinds of things that statistics can be very useful for. And certainly in modern scientific research, you aren't going to publish a paper with lots and lots of data that you haven't analyzed with the proper statistical tools. Now, when I took a philosophy of science class in college, I was shocked to learn that actually the kind of statistical testing that I'm teaching you this semester, which I was learning in college myself, is under what's called the Popperian falsificationist paradigm. This blew my mind because I thought, well, scientists decide how science is done, not philosophers. But it turns out that how we decide what we know is actually something that philosophers are responsible for. Now, in general, I would say that philosophy makes my head hurt, but it's also useful. And because we know that philosophical thinking has guided how science is actually done, we need to be aware of that. We need to think about what that means. All right. So this isn't any particular famous philosopher or even Daniel Dennett. This is just a very good picture I found that showed me sort of this level of thought that we need to bring to our endeavor. And so this quote says, "There's no such thing as philosophy-free science. There is only science whose philosophical baggage is taken on board without examination." Right. And so that means generally, like, if you just assume that science is completely objective and it has to be exactly the same way as how you've been taught, then you're not going to be using those tools properly. All right. So we're going to take a little bit more time talking about the philosophical background of scientific thinking today because um, it does inform or in fact has um, contributed to what we're actually doing. All right. So let's see what role philosophy plays as we do science. And we're going to start with the topic of epistemology. Epistemology is formally called the theory of knowledge. What does that mean? Well, it is about studying what things can we know and how do we separate those from things that are unknowable. All right. And then when we decide that there are some things we can know, how can we know them? Um, and this seems really abstract, but I have a very concrete example. And this is an image from the movie Enchanted. And if you've never seen it, it's basically a musical romantic comedy where the character played by um, uh, Amy Adams in her princess dress there basically pops out of a Disney movie into the real world. And she meets this handsome gentleman, and he is concerned with his romantic problems. And so she says, how can I help? And he's not sure that his girlfriend or fiance really knows that he loves her. And so Amy Adams' character launches into a full-scale song and dance, and sings this song. Um, how does she know? And in it, she talks about how how do you show a person that you love that you really love them, right? In a way that they recognize is love, right? So, if you're not a lovey-dovey kind of person, this example may not be striking a chord with you. But when we think about communication with other people, sometimes there's a disconnect between, maybe if I have some behaviors that I see in another person that I feel respected if I see those behaviors in that person, right? But maybe that person doesn't realize that those are the things that I recognize as respect, and they're doing something totally different than that, right? So these kinds of communications, how do we know what another person is thinking or feeling, right? They have to tell us. They could be lying, right? So it's all very fraught. Anyway, this is a fun movie. If you haven't seen it, I have this clip for you, this song in the Canvas container for you to check out later. All right, so how do we know the things we know? Now, how is it possible to know things? That's sort of the next question that epistemology asks. How can we know things, right? So there's two schools of thought that philosophers, sorry, have put themselves into these groups. And a group of them have defined knowledge as an empirical thing. That means that it comes to our brains via our senses, that the external world is real and our observations of it allow us to know the truth, right? The opposing school of thought is that knowledge comes from our mind. And the most famous quote from this group of philosophers is, I think, therefore I am. And that the only way that we can grasp or access reality is if we've thought about it. Now, these are two very different perspectives. Let me quickly give you an example of people who think these different ways, right? I'm a biologist, scientist, and my spouse is a software engineer, right? So when we need to do something like put together some IKEA furniture or move a sofa, um, I just want to grab the tools. I want to pick up the sofa. I want to try and shove it through the doorway. And if it doesn't work, then I will turn it on its side and try again. All right. My spouse is a rationalist, right? So he wants to figure things out in his head before we do anything. So I'm standing there bouncing my foot up and down, wanting to pick up the sofa, and he is sitting on the sofa trying to figure out, measuring, estimating things in his mind and trying to see, um, plan how we're going to do ahead of time. All right. So which of us is the empiricist and which is the rationalist? Well, I'm the empiricist. I just want to do something, right? Okay. So now these definitions have been developed by philosophers whose job it is hard about things. And we, as everyday normal people, can see quite easily that neither one of these types of knowledge really works all the time. Right? Sure, we can know things from the senses, but yeah, we can also know things rationally. And we can also make mistakes, not be able to see things clearly with the senses, right? Suppose you have a head cold and your head's all stuffy, and your housemate is making chocolate chip cookies. You cannot smell those cookies. Now, it's sad that you're missing out, but if you walked in the door and you didn't see the kitchen, you would not be able to tell. You would not have the knowledge of the chocolate chip cookies being made with your normal sense of smell. All right. Also, somebody could be colorblind and not be able to see colors the same way other people do. Right. We also know I, for one, have certainly made lots of mistakes when I'm trying to figure things out in my head, even when I'm using paper and pencil. So, just because we've thought it in our mind does not guarantee that it's true. All right, so we'll come back to that towards the end of this discussion. Let's turn our attention more to how scientific thinking in general developed and return to the philosophy in a minute. So globally, oh shoot, I forgot about this example. All right, so the difference between empirical and rational worlds existing is absolutely, I can't believe I forgot about this, absolutely the best portrayed in the movie The Matrix. Right. So Neo, character played by Keanu Reeves, he thinks he is going about his daily life and that he is physically experiencing his boring job, his dingy greenish apartment. He's eating lunch, he's walking around. He thinks that is the actual physical reality that he is experiencing until he meets Morpheus, who gives him the red pill. Well, he chooses to take it. Right. So what happens is that he wakes up and discovers that his actual physical body is inside of a plastic shell full of pink goo. He's hooked up to the machines and that they are taking energy from his body, just like all the other millions of humans that are stuck in these egg like containers. All right. So he was actually imagining his previous existence in his head. It was not physically real at all. All right, now let's turn our attention to the development of scientific thinking. All right, now there was plenty of science happening in the ancient world all over the globe. Thousands of years, people have been pondering the mysteries, figuring out math, um, doing philosophical thinking, and making discoveries in physics and astronomy. And this is one example. Alhazen, who lived in what's now Iraq and made discoveries, notice, across many different sciences, including philosophy. All right, so people weren't called scientists at the time. They might be called philosophers or um, natural philosophers often. All right. So there were also these kinds of logical, rational thought going on in the Arabic world, in China, India, across the continent of Africa, and also in Central and South America. Our educational tradition in the United States is based on the British system, so it's European in orientation, and the scientists we think of as inventing the scientific method, they certainly invented it, but they weren't the only people that invented it. So that's what we normally think of or are taught in Western civilization. So we have these two scientists, Francis Bacon and Isaac Newton, who were doing their work in the early 1600s and late 1700s. And this was really important because the way that they saw the world was a little different than people had in the past. So people's religious beliefs were incredibly, incredibly important and widespread and uniform across large populations at the time. And so most people believed what was in the Bible, what the church leadership told them. These gentlemen started to think about, to notice patterns in how the world worked, and they started to develop a slightly different understanding that even though things may not all be knowable and that, whatever God works in mysterious ways, there were observable patterns in how the universe worked. And they felt like by discovering and working out what these patterns and laws were about how the physical world worked, that they were actually becoming closer to understanding God himself, right? So that these observable patterns, the way that mathematics worked, it was almost as if uh, it was put there so that mankind or humankind could understand God's creation. All right, so they were religious, but they were not any longer just taking fanciful ideas and trying to find evidence that they were true. All right, so you've probably heard of the scientific method before. Important characteristic is that we're going to start by making observations, and we're going to attempt to do that as objectively and carefully, meticulously as possible. And then once we see something we think might be happening, we're going to propose it as a hypothesis, and that means it's testable, right? So if we figure we have to figure out a way we can test that idea, and if we test it and it turns out it's wrong, things don't work out that way, then we say, aha, that's more information, right? So rejecting or refuting a hypothesis is not a bad thing in science. It's okay to be wrong. In fact, if we aren't wrong, then we are never going to make any progress because we're going to come up with some crazy ideas and want to test them out. And a lot of them are just not going to be right. The important thing is that we keep trying to make better ones. All right. Okay. All right. So as the scientific method, kind of as we know of it, was being developed at this time in history, philosophers, natural philosophers were working through how can we know things in a more practical way. And they separated out two different ways of knowing. One is using deduction as the method of reasoning, and the other is using induction as the method of reasoning. All right, deduction is something you may have used if you've taken a math class where you did proofs, that you have to start out with something, a premise, right? A fact that you know is true. You get in all kinds of trouble if you start out with something that isn't true. Um, so we have to have a way of knowing our premises are true. Um, then you're going to use a set of logical steps to deduce true consequences. All right. If your premises are true, you use um, appropriate, correct logic. Anything you deduce should be true, and anybody else using the same process should be able to come to the same conclusions, right? So it's kind of deterministic. It's sort of like there's only one way you can go through those steps and you'll come to the same conclusion. All right. Induction is very different. Um, Induction is a process where you're going to observe a small number of individuals, or you're going to take what we could call a sample, right? So some instances of a phenomenon or a small number of individuals that have some characteristic. And you're going to use those individuals to figure something out. You're going to measure something on them, observe something about them. And then you're going to say, oh, everything else that I didn't observe, I'm going to say it works the same way too. All right. So your general conclusion is something that is not necessarily going to be true. It can be true, right? It could be wrong if the individuals that you observed are unusual or don't represent the true pattern. Right. So induction is an incredibly powerful way that we can sort of make these leaps of knowledge by taking a manageable sample, right? We can't observe every single instance of some kind of phenomenon or every single individual of some kind of species under a certain circumstances. Right. So we're going to say, okay, I'm going to take this whole complicated natural world and I'm going to use this process called induction. All right, I'm going to say, I can say something about this small group of individuals I observed, and then I want to apply it to unobserved individuals. That's the induction part. Okay. Now, this natural philosopher, David Hume, he pointed out this problem that our conclusions can be wrong. All right. So induction is not like deduction that we always get to the truth. All right. So the thing with induction is typically when we use that process, we're going to keep testing, we're going to keep working on the same problem. We aren't just going to use one example, one tiny little experiment, and assume that it's going to apply to all other cases. Right? And the same way we were talking about earlier, if we find contradictory evidence later on, then we will change our former conclusion. We'll reconclude. We'll update it. All right. Um, Induction and deduction are ways of knowing that we use in our everyday lives, but we use an awful lot of induction that we aren't even really aware that we're using. We're so comfortable with it that we use it all the time, all day long, basically. All right. So if I ask you a question about what the weather's going to be like tomorrow, is the weather going to be sunny tomorrow? Now I'm looking out my window here in beautiful San Diego, and indeed it is sunny today. All right. So if I think to myself, it's sunny today, it'll probably be sunny tomorrow. I live in San Diego. San Diego's a sunny place, right? Those um, types of reasoning are actually induction. All right, they're not deduction. They are induction. I have observed something, right? Or I've made an assumption based on some evidence, and I'm going to apply it to an unobserved circumstance tomorrow, right? If instead you ask me what the weather's going to be like tomorrow, and I go to my little weather station and I look at the pressure, the air pressure, I look at the humidity, I look at the temperature, I look at the dew point, I look at the pattern I've seen in those over the last week, and I use those pieces of factual information um, to say, well, I expect that the temperature will be this, the pressure will be this, the blah, 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 everything. Yes, I expect it to be sunny tomorrow. All right, now that isn't entirely a deductive argument. There's a little induction in there too. But you would have to be starting out with those pieces of factual information and not just saying, it's going to be the same as something I've already observed. All right. Another way we use induction, and this is kind of an insidious way, is when we make assumptions. Again, we do it all the time, right? So anytime you are driving down the freeway and you see somebody zooming past you and you think, oh, that person is driving an Audi. All right. They're gonna not be polite to me on the roadway. All right. You've made an assumption about a person who drives a certain kind of car, right? And you have extended perhaps one neighbor you had that drove an Audi that was rude, right? You've extended that to this group, right? Racism works the same way, all kinds of isms and uh, challenges that we find in society where we make an assumption, we apply a characteristic to a whole group of individuals based on a very small amount of knowledge, right? Or something that isn't even true. All right, let's look back again at the ideas specifically of this philosophy of science. All right, philosophy of science itself didn't really become a thing until around the early 1930s, and this is when Karl Popper, this scientific philosopher of science, defined this idea of falsification. And that idea says that we can disprove a hypothesis, but we can't prove a hypothesis. So this is going to be the explanation for when we're doing our statistical testing in this class. We will actually set up a null hypothesis that nothing happened, right? And we're going to test that null hypothesis, right? So if we disprove that null hypothesis, then we're going to have evidence that something happened, right? And we'll actually have an alternate hypothesis. Our null is going to be nothing happened. Our alternate is something happened, right? So additional work has been ongoing since that time, and it's actually a very active role of philosophical inquiry um, up to the current time. Um, and there are alternate ways of testing hypotheses that that we're not going to explore too much in this class, but I want you to be aware that this sort of basic formal statistical testing that we're learning in this class is not the only way that you can do statistical analyses and test hypotheses. All right, but overall, the philosophy of science is going to have its purpose is to develop a system of rules and practices that are most likely or under ideal circumstances to produce true information that we can learn things about the world. All right, so we talked before about how we have these empirical versus rational ways of knowing things. We know that they can be wrong, and that's basically what the philosophy of science is trying to address. How do we know? How can we know what is right in a formal and repeatable way? All right, so in the later 1900s, the endeavor of science has discovered, kind of again, that not everything is knowable, right? So we thought we could know everything about nature by, you know, examining it scientifically, taking it apart, looking at how all the parts worked. But we have actually discovered things like Einstein's theory of relativity, where what we see happening depends on our perspective, right? Or radioactive decay, where we don't know, there is no mechanism that we can observe that can tell us when a little neutron is going to go shooting off of an atom. We may ultimately find that out. We don't know it now. Heisenberg's uncertainty principle tells us that the act of observing actually interferes with the characteristic of what's being observed. And finally, most recently, chaos theory, which was developed in the probably 70s and 80s, turns out that in complex systems, and they don't have to be very complex, that we can have multiple possible outcomes. In fact, we can have an infinity of possible outcomes, all stemming from what seem like almost identical initial conditions. So our way of thinking about what is knowable has continued to evolve as these scientific discoveries have been made. And we have also increased our inclusion of different ways of knowing, the most recently with the sort of Western science, kind of scientists doing work and using standardized methods and publishing it in journal articles, has begun to embrace, especially in the field of ecology, traditional indigenous knowledge or traditional knowledge or how I've normally seen it as being used in ecology. And that is the case where local indigenous people have been making observations about the environment and about species that live there for generations and have been handing down this information, often by oral tradition, and that their knowledge is holistic, that it doesn't break things apart into separate pieces. It looks at everything taken together, that it might not be numerical measurements, that it could be descriptions of the state of things, where and when things occur, and that it has a perspective that humans are part of the environment, both in a physical way, but also a social and spiritual way. And that is very different from, the sort of Western idea that spiritual um, uh, thinking has to be separate from science. Um, However, as the practice has been growing, that it has been more and more accepted and included. So, for example, these Inuit whalers provided key information to a series of research projects on bowhead whales in the Arctic, that their traditional knowledge was included in scientific um, work that was exploring the management of bowhead whales and how it related to their historic populations. And I was fortunate to be a part of one of those projects. All right, I want to finish this lecture by giving kind of the good news and the bad news. This beautiful picture is from it's a sunrise in Antarctica, where I was on a research ship for a few weeks when I was in graduate school. I was very lucky to get to go on that trip. And this sunrise makes me think of, what do we take away from this assessment of how can we know what we know? How does statistics play a role in it? And the good news is that statistical tools actually allow us to know something because they put boundaries on our uncertainty. And that overall science is a rational process that does allow us to gain knowledge. Right? It might be slow, might have starts and stops, but it is overall an endeavor that we can feel confident is making progress. Now, this quote is from a well-known Pakistani poet and philosopher. My last philosopher we're going to talk about today. And he says, inductive reason, which alone makes man master of his environment, is an achievement. And when once born, it must be reinforced by inhibiting the growth of other modes of knowledge. Now, if you just look at the first part of this quote, you might be thinking, oh, wow, he's really endorsing this, this way of knowing. So the first part is really taken out of context without the second part. Right. So this is kind of a cynical viewpoint, um, that if you see that everything you're going to apply your scientific method, use your inductive reasoning, that can inhibit your acceptance of other ways of knowing. All right. So we've just discussed a couple different alternatives to traditional scientific, Western scientific deduction and induction are the only way that we can know things. All right, so this is just, we're going to take the reason we did this whole lecture on philosophy is that we need to always be able to take a step back and say, what's this tool we're using? How are we using it? Are we doing the right thing that makes sense here? Okay, we'll keep talking about that all semester. Um, and we'll have choices. We're gonna make choices, and there's going to be a lot of gray areas. So if you were thinking statistics is going to be something where there's right, there's wrong, it's very clean cut. that is not going to be the case at all. We have to do a lot of thinking. So we are going to learn to be thinking scientists that are going to use a tool like any tool that you use. It's nice to have it. But for my friends in the construction trades, if all you have is a hammer, don't make everything a nail. We want to have lots of tools available to us. All right. I will see you next time.